New lesson, new unit. So we got 4.1, finding minimum and maximum values. It's going to be one of the many applications of taking derivatives, which we spent quite a bit of time learning how to do both on a basic level and on an advanced level. Our objective here is to find extrema on a closed interval. Extrema is what we're calling the extreme values, the minimum and the maximum values of a particular function. We're going to start, as we often do, with a warm-up question. So we want to draw a continuous function connecting two endpoints. So here are my two endpoints, and I want to be able to draw just any kind of continuous function that connects those. A linear graph, I could do that, but it'd be totally boring. Instead, I'm going to do something with a little bit of curves to it. And would you agree that this thing is a continuous function on a closed interval? We got a closed interval because it includes point A over here and includes point B. So from whatever those points are, who knows, maybe that's 0, maybe this is like 13, whatever. Okay, and then there are no jump discontinuities, there are no asymptotes, there's no PODs, as you kids are calling them, right? Totally continuous. So the questions here, I've got a number of them. How many absolute minimum points do you have on this graph? Well, on this one in particular, absolute minimum, where does it occur? It happens right over here at point B. Here's my absolute minimum point. It's the lowest point on this whole entire graph, right? And then the next question is, how many of them do you have? Well, there's only one of them. It's the lowest point on that graph. Is that always the case? Do you always only have one? No, it's possible that you can have more than one, and I'll show you a graph of what that could look like here shortly. But for this one, I just have one. And notice that it does occur at the end point of the graph. All right. Next question, how about absolute maximum? What's the absolute maximum of this graph, and where does it happen? Here it is, right here in blue. There's the absolute maximum point. It's the highest point on this whole entire graph, of course. And it occurs at one of these peak points. So last year, you probably called that a local or a relative maximum, but it can be also an absolute maximum if it's the highest point overall. How many of them do I have? Obviously, I just have one of them on this graph. Is it possible to have more than one? Sure it is. And again, I'll show you a picture of that graph in just a moment here. All right, well, what about these other 2 points, like this one down here and this one up here? Those are minimum and maximum values. They're just not absolute. They're local or relative mins and maxes. So down here in purple, here's a relative minimum. To qualify to be a relative minimum, you have to exist on an interval. It can't be at an endpoint. There's got to be points to the left and to the right. And it's got to be the lowest point. It's not the lowest point on the whole graph, but it's the lowest point relative just to the surrounding points here. Relative, there you go. And then over here in green, we have a relative maximum. It's not the highest point overall, but it is higher than the surrounding points here on some sort of interval that contains that particular point. Okay, so let me come over here so I can draw on this graph. So when we're asking, first of all, how many? And then each one, I only had one of each one, right? I had one absolute maximum, I had one absolute minimum, but it's possible that you can have more than one of these things. What if I had drawn my endpoints like this with a parabola? And then you can see that I have two absolute maximum points and just one absolute minimum point. Think of like a sine graph, though. This is a perfect sine wave. All right, so here you can see that you have lots of absolute maximums and lots of absolute minimums as well, right? Okay, and then the other question, this is super important, it's so important, I am going to highlight it. It says, where are they? Where can they possibly occur? So notice that on this first one, absolute minimum, it happened at an end point. And then our absolute maximum, it happened at one of these kind of turning points here, right? And that's always going to be the case. It's always going to happen at a turning point or one of the endpoints. It's part of what this lesson's all about. All right, I've got one little follow-up question to do with this warm-up, and that is, well, what if the curve that we started with wasn't continuous? I just do just one little thing. It's very subtle. Did you see the difference? Here, let me go back. Let me go forward. You see how I took that point away, and now it's a point of discontinuity there, a removable discontinuity. Now am I guaranteed an absolute minimum and a maximum? Well, I still have the absolute minimum. It's still down here. But as far as the absolute maximum goes, I don't have one. I can get infinitely close to this point, but never actually reach that point. And so it has no absolute maximum. And so that's going to be one of the qualifying features to be able to be guaranteed an absolute minimum or maximum, so that your function is going to have to be continuous on a closed interval. Which brings us to our first objective here about being able to find this extrema, the absolute minimum, absolute maximum points on a closed interval. It's often called the closed interval test, and it is occasionally referred to as the candidates test, which is a reference to this picture that's right here. This was picture that was broadcast prior to the 2016 election, I believe. And in this picture, you can see a ranking of the Republican candidates for president. And it's in the shape of sort of a parabola, we can see. It's sort of like a parabola. And then the peak point there, the absolute maximum occurs right about here. Is at this turning point. Okay. All right. So in the next lesson, we're going to next video, I should say, we're going to take a look at defining some of these points and then do some exercises with them.